Hi, I'm Utkarsh.
I'm Hank.
I'm Richard. For our project, we'll be presenting on implementation of soft actor critic method. And to begin with that, we introduce the environments that we will be working in. So we'll be working on two environments, the Chim bipedal walker and the Chim walker 2D. For both these environments, the action space is continuous. For the bipedal walker 2D, the reward is given for moving forward, and for having a successful run, we need to have 300 plus points. And for walker 2D, the aim is to get as high as possible, and the average successful score is considered to be over 1,000. To introduce the active critic method, the fundamental idea of active critic method is that it combines the strength of policy gradient method and of value function approximation methods. So the critic steps estimates the value function, which can either be the Q value or the V value. And then the actor updates the policy distribution as suggested by the critic. The policies are updated by minimizing these two losses. And instead of using the traditional actor loss, we are considering actor loss to be the negative sum of all the Q values. Doing this, we'll be directing the algorithm to maximize the rewards directly.
So we first trained the actor critic, the traditional actor critic model onto environment. So for training, we train 5,000 episodes for bipedal workers and 1,000 episodes for worker 2D. The max steps is 1,000 in each episode, and the max buffer size is 1 million. So during training, we use exploration strategy to get actions and store the tuple of current state, action, reward, and new state in the buffer. And then after each episode, we sample 128 tuples from the buffer to train actor and critic network. And after training, we rerun the environment by exploration strategy, which is action generated by the target actor for validation of each episode. So this is the validation reward for over 5,000 episodes for the bipedal workers, and as you can see that it gets to over 300 after 1,000 episodes, and then gets stable and becomes optimal around episode 2,400. And so this is a validation reward for worker 2D. So as you can see that it reaches its maximum around episode 110. And then we extract models from optimal episode and then run that model 100 times with exploration to do the test. So as this is the test for bipedal workers, and as you can see that in most episodes it reaches over 300, and the average return is 279, which is close to 300. So the actor critic model works well for the bipedal workers. And as for the worker 2D, the total return is around 300. So which means that the actor critic does not work very well in this environment.
All right, so next I'm going to be talking about the soft actor critic algorithm. And this was sort of an idea that came from Thomas Harnoja in 2019. So he did this in 2 papers. And there are sort of 2 ideas, and I'll call them SAC1 and SAC2 for now. And so there's sort of the usual stuff, and a replay buffer, sort of these neural networks. The policy network is a little bit different. It samples from a Gaussian and then it's plugged to a tanh function, but that's not super important. So the idea behind the soft actor critic in general is that it's much similar to the regular actor critic framework, with the addition that it seeks to maximize the entropy of the policy. And what that does is that it kind of allows the different Q values that are really sort of similar to have similar probabilities. And the higher entropy in the policy also encourages exploration. And so we have this modified reinforcement learning objective, which has this alpha, which is a parameter called the temperature. We'll talk about that a little bit more later, times the entropy. And so in SAC1, alpha is this parameter that needs tuning. And you can see that we can see later that it's going to be a little bit brittle in terms of that. And in SAC2, we actually develop an algorithm to automatically learn this alpha parameter. And so in SAC1, we have these networks that are parameterized by these Greek alphabet letters. There's this little target right here. the loss functions. And as we can see in SAC1, remember, this is the one where we don't really have, so this parameter is not automatically tuned. We see that it performs quite well on the Walker 2D environment compared to Actor Critic, but it doesn't perform that well on the bipedal Walker compared to Actor Critic. It actually fails to converge. So SAC2 has this idea of sort of improving or not improving, automatically learning this temperature alpha using a sort of neural network methods. And as you can see, this is the loss function that we're trying to optimize to get to that optimal alpha. And so if we look at our results, we can see that it actually performs better in both environments than the Actor Critic or the SAC1.